Today we're going to do the lab called Odds or Even. Turn to your packet here. Okay, if you are just reviewing this, you can go ahead and review our answers. If you're not, if you'd like to go ahead and do this, this is basically what we did. We took two dice and we rolled them. And then we see like if we got a 6 and a 5. And then we multiplied them. 6 times 5 is 30. So evens win. So we went ahead and did that, and we played 20 different times, and then we found a percentage to see, okay, who won. So what I had the class do is I said, okay, I want you to go ahead and report to me what percentage of time did odds win? So, we had people between sometimes 0% all the way up to about 50% or so. But most people's were right in there at 25%. So when you look and you see that actually odds do win exactly 25% of the time. And when you start doing the simulations, you start seeing that it gets really close to 25% most of the time. So the class data is obviously closer to the actual probability more often than not, because it's a long-term probability. Now, one person might have gotten 25%, or 2 or 3 or 4 might have gotten exactly 25%. But in general, when you put the whole class data together, it finds the average right at 25%, which is more accurate than any one particular person's simulation. This chart is just all the products, 1 times 1, 2 times 2, et cetera, et cetera. And this is what helps us kind of figure out how many times do odds win. All right, for these particular problems, 4 or a 5, remember, these are disjoint. So what's the probability of getting a 4? What's the probability of getting a 5? Now, disjoint probabilities, you are able to add them and subtract no overlap. Disjoint probabilities means I cannot roll a 4 and a 5 at the exact same time. So they cannot have an overlap. So that's why I can just go ahead and add them together, not have an overlap. So what I'm doing here, I'm saying I cannot get the product of a 4 and the product of a 5 at the same time. So I just add up all the 4s and add up all the 5s that are here, and that's where I get the 3 over 36 plus 2 over 36. A number besides 6, okay, that is either 6 or not 6. Those are the complements. So complements 1 minus what it is not, or what it is, and that's what it is not. So 1 minus 6, which is there's 4 out of 36. If you see, there's 1, 2, 3, 4. So 32 out of 36 are not. A number between 1 and 36, well, that's all of them. Every single one of them here are between 1 and 36. All right. The notes to remember for today is remembering on the probability model, the list shows all possible outcomes and their probabilities. They have to add up to 1, and each probability is between 0 and 1. A complement event is the probability of an event not happening. So this would be something like raining, not raining, where the two events add up to 1. If the probability of it raining is 80%, the probability of it not raining is 20%. This would not be like if you said red, blue, and yellow. What's the probability of me picking a red? Well, it would 1 minus the probability of yellow. Well, no, because I have blue, red, and yellow, because there's 3 different probabilities. This is only when there's 2 probabilities and one is and the other is not. Now, I could have the marble situation. Instead of saying red, yellow, blue, I could say yellow and not yellow, and that would be fine because I'm setting up in a situation of 2. Okay, mutually exclusive or disjoint events means, again, things that cannot occur at the same time. I cannot draw a red and I cannot draw a blue at the same time for one pull. A general addition rule, the probability of A or B is equal to the probability of A plus the probability of B minus nothing if it is mutually exclusive. But if it's not mutually exclusive, which this one doesn't necessarily say it is, you need to make sure you subtract the overlap, which is A and B. That's the general addition rule. Okay, the addition rule for mutually exclusive events is exactly that, where it's just the probability of A or B is the probability of A plus the probability of B. There's no overlap for mutually exclusive because it's literally raining, not raining. You know, there's no overlap. One here and one here. But there's nothing similar in common. Okay, so for this first question, it asks why is the probability valid? And it's valid because if you add all of these probabilities, you have a total of 1. And each one is in between 0 and 1, each probability. The reason red and blue are mutually exclusive is because I can't get a red and a blue with one pull at the same time. The probability you don't get a blue M&M, I look at blue and I get 0.207. So which is be complementary of blue, which is 1 minus blue. The probability you do get an orange or a brown, probability of orange or brown. Now these are disjoint events. I do not have an overlap, so I can just add the two probabilities together. The probability I don't get a red or a green, so I say, okay, red or green, and then don't. So that's opposite. And don't does this, 1 minus. Red or green. So I am going to say 1 minus 0.131 minus 0.198. All right, thank you very much.